Let's revise epidemiology with me. Epidemiology is study of distribution and determinants of health-related states, health-related event, and application of that study to solve health problems. There are various tools in epidemiology, and they are rate, ratio, and proportion. Rate is occurrence of event in a defined population in a given period of time. इसके elements हैं numerator, denominator, multiplier and time. Ratio is relation between two random quantities. Here numerator is not the part of denominator. Example is maternal mortality ratio. Proportion is relation in magnitude as a part of whole. Percentage में से express करते हैं. Other tools are mortality. Mortality measurements are easy to obtain, reasonably accurate, and they are measured by death certificate, which is basis of mortality data and is uniform and standardized. It includes causes of death. Part 1 includes cause of death and underlying causes. And part 2 includes associated diseases. Types of mortality indicators are crude death rate, specific death rate, case fatality rate, and proportional mortality rate, and standardized rates. Crude death rate is number of deaths per 1000 mid-year population. इसका multiplier 1000 है. Specific death rate is specific to age, sex and disease. Case fatality rate is number of deaths per number of cases into 100. Tells us about killing power of disease. Virulence of disease. Proportional mortality rate is proportion of population died due to a particular disease. What is survivor rate? Survivor rate is number of survivor per number of disease diagnosed into 100. It is shown by life table analysis, Kaplan-Meier. Now let's discuss standardized mortality ratio. It is the ratio of observed death divided by expected into 100. More than 100 describes greater mortality. Another tool is morbidity, which is any departure, subjective or objective, from a state of physiological well-being. Morbidity is calculated by incidence and prevalence. Incidence is number of new cases per 1000 population at risk. Incidence rate is number of cases in a given time in a specified population or population at risk. Special incidence rates are attack rate and secondary attack rate. Attack rate is number of new cases per 100 population at risk. Secondary attack rate is number of exposed person developing disease within incubation period following the exposure by primary case. Let's discuss prevalence. Prevalence is all the current cases in a defined time. It can be of two types, point prevalence and period prevalence. Point prevalence number of current cases in a given point of time. Period is number of cases in given period of time. Now what is relationship between incidence and prevalence? Prevalence is equal to incidence into duration of time. There are various methods through which we can study epidemiology of a disease. The first method is observational and the second is experimental. Observational में we allow the nature to take its own course. Observational के types हमारे पास descriptive and analytic. Descriptive में we describe time, place and person. Time variation there can be short-term fluctuations, there can be periodic fluctuations and long-term fluctuations. Short-term fluctuations include common source, propagated and slow. Common source के further types हैं point and continuous. It can be represented by a epidemic curve. Epidemic curve basically graphical representation होती है of number of new cases over a period of time. So this is the graph showing time and cases. If we plot the cases, this is showing point source. Single source is there, only single peak you can see. All the cases come in one incubation period. One peak is there and median incubation is time required for 50% of cases to occur. Now let's see the graph of continuous exposure. Here we can see plateau. Here epidemic is continued for more than one incubation period. Peak absent होती है, plateau is present. For example, waterborne diseases. This is the continuous source epidemic and this is the intermittent source epidemic. multiple peaks are there. Now propagated epidemics में person to person transmission होती है, so gradual rise and gradual fall is there. And this can be seen when there are large number of susceptible individuals. Long-term fluctuations NCTs में and periodic fluctuations can be seasonal and cyclic. Seasonal fluctuation में हमारे पास measles आता है spring में, upper respiratory tract infection winter and GI in summer. Cyclic epidemic repeats over a period of time, days or weeks. इसके example हैं, for example pre-vaccination era में measles and rubella and influenza peak होता है हर 7 से 8 साल. Now place की बात करेंगे तो places there can be international variation जैसे कि stomach cancer जापान और oral इंडिया में. नेशनल लेवल पे एपिडेमिक क्वाइटर हमें दिखता है और लोकल लेवल पे वी कैन सी द स्पॉट मैप. वी कैन मेक द स्पॉट मैप. जॉन स्नो ने सबसे पहले बनाया था फॉर कॉलरा. कॉलरा केसेस को हम डॉट से रिप्रेजेंट करेंगे एंड दिस इज द फेमस वाटर पम्प. इट शोज द डिस्ट्रीब्यूशन ऑफ केसेस, help to identify the sources and pattern, and it is simple, easy to understand. Now, person variation can be because of age, occupation. Then comes the analytical studies. So, epidemiological methods में हमने observational, experimental देखा. Observational में descriptive और analytic. Descriptive में time, place and person और analytic में cohort and case control studies आती हैं. So, let's talk about one study that is cross-sectional study. इसमें हम single examination करते हैं. We measure the exposure and outcome at the same time. प्रेवलेंस हम इजीली कैलकुलेट कर सकते हैं इससे. देयर इज वन मोर स्टडी दैट इज इकोलॉजिकल स्टडी जिसमें बेसिक यूनिट इज पॉपुलेशन. इकोलॉजिकल फैलेसी इज द मेजर लिमिटेशन ऑफ इकोलॉजिकल स्टडी विच इज द एरर ऑफ अप्लाइंग रिजल्ट्स ऑन इंडिविजुअल फ्रॉम अ पॉपुलेशन डेटा. Let's come to analytical studies. Major analytical studies like cohort and case control. केस कंट्रोल में वी स्टडी फ्रॉम आउटकम टू एक्सपोजर. इफेक्ट से कॉज की तरफ जाते हैं. तो पॉपुलेशन से हम केसेस और कंट्रोल लेते हैं. देन वी स्टडी एक्सपोजर एंड नॉन एक्सपोजर. नाउ इसके स्टेप्स हैं. फर्स्ट इज सिलेक्शन ऑफ केसेस एंड देन कंट्रोल्स. तो केसेस को हम हॉस्पिटल या जनरल पॉपुलेशन से ले सकते हैं. कंट्रोल को हम हॉस्पिटल, रिलेटिव्स, नेबर्स या जनरल पॉपुलेशन से. मैचिंग इज द मेजर इंपॉर्टेंट स्टेप. Selecting controls in a such a way that they are similar to cases in form of age, sex, etc. for preventing confounding. So what is confounding? Confounding error is a systematic error and this factor is associated with exposure, independent predictor of outcome and not in a causal pathway. So इसका example है. For example, if exposure is coffee and outcome is we are seeing a cancer, then confounding can be smoking. Smoking is the confounding. It is associated with exposure. That is, smoking is associated with coffee and it is independent predictor of cancer, but not in the causal pathway. Smoking causal pathway में नहीं है. तो matching prevent करता है confounding को. So cases and controls should be matched so that age, sex, etc. confounding ना बने. Now third important step is analysis. केस कंट्रोल इंसिडेंस नहीं कैलकुलेट करते. ऑड्स रेशियो इसमें कैलकुलेट होती है. सो हाउ डू वी कैलकुलेट ऑड्स रेशियो? फॉर एग्जाम्पल फर्स्ट वी हैव टू ड्रॉ दिस टेबल. सो फर्स्ट सेल में हमारे पास ए है, सेकेंड सेल में बी, सी एंड डी. सो इनके क्रॉस प्रोडक्ट को हम ऑड्स रेशियो बोलेंगे. दैट इज ATPC इज ऑड्स रेशियो. सो ऑड्स रेशियो 1 नो एसोसिएशन, लेस देन 1 ऑड्स रेशियो मीन्स लोअर ऑड्स, यानी कि एक्सपोजर इज एसोसिएटेड विद लोअर ऑड्स ऑफ आउटकम. ऑड्स रेशियो मोर देन 1 इंडिकेट्स हायर ऑड्स. केस कंट्रोल स्टडी की कई एडवांटेजेस हैं. इट इज इजी, इनएक्सपेंसिव एंड गुड फॉर रेयर डिजीज एंड देयर इज नो एट्रिशन, यानी कि नो लॉस टू फॉलो. Disadvantages, it has biases like recall bias. So what are biases? Biases are basically systematic error in a study design, conduct or analysis that leads to false estimate of association between exposure and outcome. In case control biases is memory recall bias. Okay, incidence cannot be measured. It is the major disadvantage. Major examples are, some of the historical studies are adenocarcinoma study, OCP and thromboembolism study, and thalidomide study. So now let's talk about the cohort studies. So cohort means group of people who share a common characteristics. Example are birth cohort and marriage cohort. In cohort study, we study from exposure to outcome, cause to effect. And steps of cohort study are, first of all, selection of major steps are selecting the study subjects and comparison. Study subjects can be general or special. For example, radiologist from X-ray exposure. Comparison can be done from internal comparison, external comparison, and comparison with general population. Then we follow up and then we analyze the data. Analysis can be done from incidence rate and estimation risk. Incidence rate are incidence in exposed and non-exposed, and estimation risk are risk ratio and attributable risk. Risk ratio is the ratio of incidence in exposed to the incidence in non-exposed. And attributable risk is incidence in exposed minus incidence in non-exposed divided by incidence in exposed. Okay. So risk ratio, if it comes 0.25, that means 75% of reduction in incidence in exposed compared to non-exposed. Now let's talk about population attributable risk, which is incidence in total population minus incidence of disease among non-exposed. So it is amount of disease reduced in a population if suspected factor is eliminated in the population. Now, attributable risk is what extent that disease is attributed to the exposure. Relative risk can be 1, less than 1, or more than 1. 1 means there is no association. Less than 1 means risk is lower in exposed, and more than 1 means risk is higher in exposed. Major historical examples of cohort study is Dolan Hill study and Framingham Heart study, which is done in 1948. 30 to 49 years of individual are taken. Total of 5,127 participants participated, and it derived the risk factors of cardiovascular diseases. Major advantage of cohort study is we can calculate the incidence. Multiple outcomes can be calculated at the same time. Major disadvantage is longer time is required and attrition bias is there and more funding is required. Let us talk about randomized control trials, where basic steps are drawing the protocol, selecting the reference and experimental participants, and randomization, giving the intervention and following up and then assessing. प्रोटोकॉल में हम एम्स एंड ऑब्जेक्टिव डिसाइड करते हैं, सैम्पल साइज डिसाइड करते हैं एंड वी स्टिक टू द प्रोटोकॉल. पार्टिसिपेंट से हम इन्फॉर्म्ड कंसेंट लेते हैं. Randomization is statistical procedure in which participants are allocated into control or experimental population. It eliminates the bias and matching is already done. Then we give the intervention. So another major important step is blinding, which can be single, double or triple. Single blinding में only participant is not aware, double में doctor is also not aware, and in triple even the analyst is not aware. Major study designs are concurrent and crossover. Crossover में each patient serve as his own control, and concurrent में there are two groups. One is experimental and other is non-experimental. In crossover, the patients are randomized into experimental and non-experimental group, and then there is carryover time where no group takes any treatment, and then there is crossover in which previous experimental group becomes non-experimental and non-experimental group becomes experimental. How do we interpret the results of clinical trial? We interpret them by intention to treat or per protocol. In intention to treat, we analyze as randomized, and per protocol, we analyze as treated. In intention to treat, dropouts are kept in analysis, and in per protocol, they are excluded. Now, types of RCT are clinical trial, preventive trial, risk factor trial, cessation experiment, and evaluation of health services. Association between exposure and outcome can be spurious, indirect, and direct. Spurious means false association. Indirect is related to the confounding, that is third factor, and direct can be of two types, one to one and multifactorial. One to one can be of four types, necessary and sufficient. For example, rabies infection causes rabies. Necessary but not sufficient. For example, tuberculosis bacilli require additional factors such as host susceptibility. Sufficient but not necessary, like radiation causes leukemia, but leukemia can be caused by other factors like benzene. Neither necessary nor sufficient, like coronary heart disease, which is caused by high fat diet. Only high fat diet does not guarantee CHD, and CHD can develop without high fat diet. Interaction in multifactorial factors can be of various types, like synergism, in which formula 1 plus 1 is more than 2. यानी कि risk gets multiplied. For example, smoking and asbestos. Then we have antagonism, where formula 1 plus 1 is less than 2. यानी कि risk gets reduced. For example, smoking reduces endometrial cancer. Then we have another interaction, that is effect modification, where third factor changes direction or intensity of exposure disease relation. For example, vaccination is more protective in young adults. Whether exposure has caused disease or not is shown by causality. Causality is shown by Bradford Hill criteria, which are about 8 criteria. First is temporality, that is, cause occur before the effect. For example, smoking occurs before the lung cancer. Then strength of association, which means stronger the association, higher the likelihood of disease. Third is specificity, one cause, one effect. It is not always present. Fourth one is consistency, which is shown in first study, second study, and third study. Fifth one is biological plausibility. There should be biological explanation behind the cause. Sixth one is coherence. It should be concurrent with the current knowledge. Seventh one is dose response, which means higher the dose, higher the risk of having disease. Eighth one involves the experiment. So there should be an experimental evidence for that particular risk factor. तो इसका निमोनिक हो सकता है, the strong smoker can't breathe clearly. T से temporality, S से strength, then S से specificity, then consistency, then comes biological plausibility, and C से coherent. Okay, where epidemiology is being used. First of all, study of rise and fall of diseases which are not constant, they change over time. Then community diagnosis, identification of health problems in a community in terms of mortality, morbidity, rate, and ratio. Then comes planning and evaluation. For allocating resources, epidemiology is important. Then evaluation of individual risk. What is incidence rate, specific rates, whether the individual is at high risk or not. Syndrome identification में भी ये बहुत help करता है. Then completing the natural history of disease, how the disease is progressing. For finding the risk factors, biological, congenital, environmental, nutritional.